Greetings, math fans. All right, so today what we're going to do is we're going to graph these polar graphs by hand. Yesterday we did everything on the graphing calculator just to kind of see what everything looked like. That actually kind of helps us just with identifying the graph, so we can kind of, we do plot some points, we can kind of see what it looks like. Okay? All right, so basically what I'm going to do here is I am going to plot 4 points for every graph except for roses and lines, okay, and maybe one additional graph. But for most of them, for the circles and for the limacons with a loop, limacons without a loop, and cardioids, you're going to graph 3 points. We're going to kind of get an idea what those points look like, and then we're going to be able to make a graph pretty easily. All right, our 4 points that we're going to graph are basically the x and y intercepts. Okay, so you guys, first of all, should look at this, right? This is 3 sine of theta, and you guys should say to yourself, oh, okay, this is a circle. Now, I know some of you guys might say this is a rose, but it's a one-petal rose, and we don't have one-petal roses. One-petal roses are circles. So this is a circle. All right, and the symmetry, of course, it's sine, y sine, so it's y-axis. Okay, symmetric about the y-axis. So here's the deal. We're going to do 0 degrees, which is a, right, think of this as the x-axis, right? So it's an x-intercept. And so it's going to be r equals 3 sine of 0 degrees, putting in 0 in for theta. So we have r is equal to 3. What's sine of 0? You guys need to know that. Sine of 0, remember, it starts at 0, so it's 0. So the answer is 0. So that's a coordinate. It's r is 0, comma 0 degrees. That's my first coordinate. The next one is going to be 90 degrees, which is a y-intercept. So it's r equals 3 sine of 90. So it's 3 times sine of 90 is 1, so it's 3. So we're going to graph, remember, r comma theta, so 3 comma 90 degrees. The next one's going to be 180 degrees. So the y-intercept, r equals, or sorry, it's x-intercept, r equals 3 sine of 180. So it's again 0, right? So 3 times 0, which is 0. So it's going to be 0 comma 180. And then we're going to do 270, which is a y-intercept. So it's r is equal to 3 sine of 270. Sine of 270 is negative 1. So it's negative 3. So we've got negative 3 comma 270. That's it. Those are the 4 points we're going to plot. All right. Let me make this in a different color so we can see it easily. We have the first one where is on the origin. 3 comma 90 is, remember, you do the theta first, so we go up 1, 2, 3, and 90. 0, 180, where's that? Well, that's on the origin as well, isn't it? Right, because it's r is 0. Remember, you always do the theta first, and then you do the r. Well, there's no place to go with the r. Okay, so that's the same point. And then negative 3, 270. So 270 is down, and then we go the other way, negative 3. So 3 up, 1, 2, 3. That's the same point. So truly, math fans, we only have 2 points. And that's okay, though. You recognize the circle, and so here, this is what our circle looks like. Okay, it's not a great circle, but that's what the circle looks like. Okay, it's not bad. Okay, let's do the next one here. Okay, what do you guys recognize this one as? Remember, the numbers are the same. So if the same, it's true love, which means it's a cardioid, which is a type of limason. Remember that. But it's a more specific name is cardioid. Symmetry, it's sine, so it's the y-axis, because y sin. Okay, and let's plot it. So we're going to do our x-intercept first. So we got 0 degrees. So it's r equals 2 plus 2 sine of 0 degrees, which is 2 plus 2, and sine of 0 is 0. So it's just 2. So that coordinate is 2 comma 0 degrees. And we're going to do a y-intercept is 90 degrees. So r equals 2 plus 2 sine of 90, which is 2 plus 2 sine of 90 is 1. So you get 4. So it's 4 comma 90 degrees. Another x-intercept is 180 degrees. So r equals 2 plus 2 sine of 180, which is 2 plus 2 times 0 again, which again is 2. So it's 2 comma 180. And then another y-intercept, 270. So r equals 2 plus 2 sine of 270, which is 2 plus 2 times sine of 270 is negative 1. So it's going to be 0, right? 2 minus 2 is 0. So we have 0 comma 270. All right, so let's plot these points here. Again, I'm going to do it in red. So it's 2 comma 0. So it's 0 degrees. And so we go out 1, 2. We go out to here. And then 4 comma 90 means go to 90. Then we go 1, 2, 3, 4. And then 2 comma 180 means we go 1, 2 over here. And 0 to 70 means we don't go anything, and we go 270, but that's going to be the origin. So notice the 3 dots in a row here, and so this is what my graph looks like. It's a curved. Okay, so it's a nice curve like that, and this is kind of the butt cheek look here. Upside down heart, which again you send if you the relationship is all over. You send the 2 plus 2 sine of theta to your significant other. Okay, just trying to give you a little advice here. Okay, so notice where the dots are. They're all in a row. Okay, we'll come back to that in a little bit, but let's keep going here. So it's 3 plus 2 cosine of theta. So what do you guys recognize this one as? Right, 3 is greater than 2. And what is greater? Greater is, get out of here, loop! So it's a limousin without a loop. Symmetry, it's cosine, so it's x-axis. Okay, so let's do it. I got an x-intercept. And so that's going to be 0 degrees. So r equals 3 plus 2 cosine of 0, which is 3 plus cosine of 0 is 1, so it's 2. So we got a 5 here. So it's 5 comma 0 degrees. And we have a y-intercept of 90. R equals 3 plus 2 cosine of 90, which is 3 plus 2 times 0, right? Which is 3. So we have 3 comma 90. Another x-intercept is 180. So r equals 3 plus 2 cosine of 180. So it's 3 plus 2 cosine of 180 is negative 1. So 3 minus 2 is 1. So we have 1 comma 180. And another int 270. So r equals 3 plus 2 cosine of 270. So it's 3 plus 2 cosine of 270 is 0. So we wind up getting 3 comma, it's a 3. I can write that equals 3. So it's 3 comma 270. Okay, so let's see what that baby looks like. 5 comma 0 is 1, 2, 3, 4, 5. 3 comma 90 is 1, 2, 3. 1 comma 180 is right here. And 3 comma 270 is 1, 2, 3. So this is giving me a sideways one, which is fine. It's cosine. And notice it bumps out a little bit. And this is a limousin without a loop. So that's your flat spot. So it looks like this. Okay, so this again, this is kind of a flat spot up here, right there. Okay, it's like a guitar pick. Looks like it. All right. So that's a limousin without a loop. Okay, let's keep going here. Excellent, excellent. So remember 2 is less than 3. So less is loop, so this is going to have a loop in it. All right, so it's a limousin with a loop, because less is loop. And symmetry, cosine, so it's x-axis. So let's do it. An x-intercept is is going to be when theta is 0, so we have 2 minus 3 cosine of 0, which is 2 minus 3 times 1, or 3, which is negative 1. So we have negative 1 comma 0 degrees. Another y-intercept, 2 minus 3 cosine of 90. Cosine of 90 is 0, so it's 2 minus 0, which is 2. So it's 2 comma 90. An x-intercept is 2 minus 3 cosine of 180. And cosine of 180 is negative 1, so that means it's 2 plus 3, which is 5. So it's 5 180. And then another y-intercept is 2 minus 3 cosine of 270, which is 2 cosine of 270 is 0, so minus 3 times 0. So it's 2 minus 0 is 2. So that's going to be 2 comma 270. Okay, so let's graph this baby. Negative 1, 0, so it means you go to 0, then you go to negative 1, so it's right over here. 2 comma 290, so 1, 2, we're right here. 5, 180, that means you go to 180, we go 1, 2, 3, 4, 5. And 2 comma 270 is 1, 2. So notice that dot, this one dot here that we did the 5 comma, or the negative 1, 0, that's like an indentation now. So this is what this one's going to look like. It's kind of an interesting one, but it's going to look like this. And there's a loop here. Okay, so this is like the bottom of the loop. It's again not a great sketch, but there's a loop in there. So let's leave this on with a loop. Okay, pretty straightforward. All right, so these are, the next two are roses. You guys should recognize those. R equals 5 cosine of 3 theta, and R equals negative 6 sine of 4 theta. So let's just kind of write that out here. These are roses. So it's rose symmetry, it's cosine, so it's x-axis. All right, so intercepts or information for roses. So now you're going to tell me, we're looking for the tips of each petal, because that's how we're going to graph it. Okay? And I want you guys to understand, first of all, that the length of a petal equals 5. That's that number right here. That's that 5. Okay? So I want to know where R is equal to 5, because I want to graph the tips of the petals. So what I'm going to do is I'm going to say 5 cosine of 3 theta. I want to know where it's equal to 5. That's going to give me the tip of one petal. So let's divide by 5. So I get cosine of 3 theta is equal to 1. Okay? And then what you're going to do is you're going to say the cosine of what is 1. So the cosine of what angle equals 1. Won't you guys agree it's 0 degrees? So I'm going to say that 3 theta equals 0, because that's what I'm taking the cosine of. Well, it's this guy right here, really. I'm saying the cosine of 0 degrees is 1. So that means that 3 theta is equal to equals 0, because cosine is 0, right? That's just like replacing that with the 0. And then what I'm going to do is I'm going to solve for theta. So I'm going to divide both sides by 3. And I get theta equals 0 degrees. That's one tip. And what I'm going to do is I know there are how many petals, right? It's 3, so there are 3 petals. And they're evenly spaced. So evenly spaced around 360 degrees. So what do? You guys should almost remember that. 360 divided by 3. Because 3 petals. Okay? And that's equal to 120 degrees. That's the spacing. And then what I'm going to do, so one petal is at 0 degrees. That's the first one. And then I'm going to just add 120 to that. So I get 120 degrees. That's the next petal. I'm going to add 120 to that. And I get 240 degrees. So those are my 3 petals, math fans. And if I make a mistake and I add another 120, I would get 360 would bring me back to 0, so I wouldn't want that anyway. Okay, but that, just know that you have 3 pedals. And then what I'm going to do is I'm going to plot these. So you guys understand that it's each one is it's one at 0, 120, and 240, and the length of the pedal is 5. So it's really 5 as an R value, 0 degrees, and 5, 120, and 5, 240. That's what I'm graphing. So let's do that. 5, 0. So 1, 2, 3, 4, 5. 5, 120. It's right here. And 5, 240. Right here. And then we just make a sketch. Like that. Like that. And like that. Okay, nice evenly spaced. Much nicer than the graphing calculator one where I just kind of randomly sketched it. Okay, so that looks pretty good. Let's graph. And notice how I graphed it? That's truly not how the graphing calculator graphed it, right? In fact, if I would kind of follow along here, the graphing calculator did it completely different. Okay, because it's not like it goes in order of each pedal. Okay, it would probably go something like this. I'm going to trace it with a yellow marker. Go like that, to that, to that, to that, to that. And actually, then it did it again, right? Then went around again. Okay, because remember, a 3-pedal roll is really sketching 6 pedals, but 3 are overlapping. Okay, that's why you don't even recognize it. All right, so let's do number 6. And again, you guys should recognize this as a rose again, because it has its R equals -6 sine of 4 theta. All right, so this is a rose. Symmetry, it's sine, so it's y-axis. And well, how many pedals does this have? Well, first of all, let's do the length of the pedal. The length is 6. Please don't tell me -6. Length is 6. And you're going to say it's 4 theta. It's an even number, so I have 8 pedals. Okay, so you're going to say sine of 4 theta. Obviously, -6 sine of 4 theta, and that's equal to the length of the pedal, because you want to find out where that maximum length is. So that's what you set it equal to 6, just like the one above here. I set it equal to 5, right? Right here. Set it equal to 5. Okay, so let's keep going here. Divide by -6. So I get sine of 4 theta equals -1. Okay. And then I say, well, the sine of what is -1? Okay, and the sine of 270. So I need to make that 4 theta equal to 270 degrees. So that's what I do. 4 theta equals 270 degrees. Okay, and then I solve for it. I get divide by 4. And I get theta is equal to, well, that's kind of a weird number, but that's okay. If you put it in your calculator, you wind up getting 67.5. So that's the location of one pedal. That doesn't mean it's going to start there. In fact, what happens is, do you guys agree? Let's just do our thetas here. So our theta is, and the spacing, let's do spacing. That's important. Spacing, since there are 8 pedals, do you guys agree it's going to be 360 divided by 8? Which is 45 degrees. That's the spacing between the pedals. So our first theta is 67.5. If I add 45 to that, that's what I'm doing, my next one comes out to be 112.5 degrees. And let's keep going. It's 157.5 degrees, and 202.5 degrees, and 247.5 degrees, and 292.5 degrees, and 337.5 degrees. Well, I count 1, 2, 3, 4, 5, 6, 7. Boo! I'm missing one. If I add 360 to that, that's actually really bad, because I'll get, or I'm sorry, if I add another 45, I'm going to go above 360. But think about it, math fans. I've got 67.5 here. Can I subtract 45? And if I do that, I get 22.5 degrees as well. Okay, so those are my 6 locations for my pedals. All right? All right, so let's graph them. Okay, again, this is kind of a rough estimate here. I mean, it's 22.5, and the length of the pedal is 6, so we're all the way out to the edge here. So it's this is 22.5 here, and 67.5 is about here, and 112.5 about here, and 157.5 is about here, and 202.5 is about here, and 247 is about there, 292.5 about there, and 337.5 is about there. Okay, so we got our 8 pedals, nice, looks nice and symmetrical, and we make a nice sketch here. And again, this is not the order that it's really graphed, but that's fine. As long as you understand that it's not graphed this way. Okay, that's it. That's kind of a nice looking rose. Okay, it's an 8 petal rose. Looks pretty good. So you might want to send a dozen of these to your significant other on Valentine's Day with, of course, a right side up cardioid. Don't do the upside down ones. Very, very bad. All right, we got 2 more graphs here, math fans. Theta is equal to 5 pi over 6, and r is equal to negative 5. Well, what is 5 pi over 6? Well, it's kind of nice actually to put that into degrees. And if I do that, I get it's 150 degrees. So if I go to 150 degrees and I graph it, let's do that in red again, just so it's a little bit darker. So do you guys agree that 150 degrees is like this? Okay. Do you guys agree with that? That looks pretty good. All right. Let's move on to the next problem. So do you guys agree the name of the graph is array, right? Well, hold on a second. Okay. Let's just pick some points here, right? You guys agree it's 5 pi over 6 at r equals 1 and 2 and 3 and 4 and 5 and 6. That's cool, and I can keep going out 7, 8, 9, and keep going out. What happens when r is negative? Well, doesn't it go the other way? So it really looks like this, math fans. It's not array. It's actually a line because r can be negative as well. So that's what this is. This is a line. Okay, so I mean, think about it. When I actually did the tangent of I think it's kind of a good show here. When I converted equations, and if I take the tangent of both sides, do you guys agree that tangent is y over x, and tangent of 5 pi over 6 is 30 degrees, and it rules there. But it's negative, so it's negative root 3 over 3. You guys agree with that? And if I I multiply both sides by x, I get y equals negative root 3 over 3 times x. Which I know it's kind of hard to see that, but the slope is negative, which this is a negative slope. It's down root 3 over 3, and so it's down a little bit and over a lot more. That's why it's kind of not a very steep slope. It's a very shallow slope. Okay? So just to kind of see that's what the graph looks like, but it's also a linear equation, y equals negative root 3 over 3x. All right, that's cool. R equals negative 5. Well, how do you draw a negative 5 for r? I mean, I understand how to do an r equals 5. You just draw it, like go out 5, but negative 5? Well, does it really matter? I mean, think about it. If I take negative 5, well, first of all, if I square both sides, I get r squared equals 25. So it's x squared plus y squared equals 25. So really, you guys know this is a circle, okay? But if I say negative 5, let me give you a coordinate. How about negative 5 comma 0 degrees? Well, where is that? Isn't that right here? And if I did, negative 5 comma 90 degrees, well, where's that? I go to 90 degrees, but then I go the other way. So isn't that over here? So truly, this is a circle, math fans. Let's see if I can actually sketch it nicely here. Okay? So it's a circle, radius of 5. It doesn't matter. So it's not an imploded, like, black hole star at negative 5. It's just r equals, the same thing as r equals 5. Remember when you actually give me an answer and you say r equals plus or minus 5? Those are exactly the same thing. A negative 5 or positive 5 is exactly the same thing. All right, so I just kind of want to point that out. So anyway, these are all the graphs here. Going back to, I know we already did this here, but I think it's good to point this out. If you go back to you see the cardioid, how the 3 dots are in a row? So number 2, okay, right? Let me highlight these. See these 3 dots right here? They're in a row. Go down to the next one and notice these 3 dots. You got one here, and this one's kind of like pushed out a little bit. Okay, so that's a lima sound without a loop. And then let's do one more here. We come down to this guy, and this one is 3 dots, and this one's pushed in. And that pushed in means you get a loop. Okay, just to kind of have you guys understand a little bit what it looks like for the different graphs. All right. Anyway, that's it, math fans. Hopefully you guys are good to go with these graphs. Just to be able to graph them by hand and recognize them. All right. And just like I said, plot your points that you need, either intercepts or ends of petals of roses, or if it's a line or circle, it's even easier. All right. That's it, math fans. Have an outstanding day. Adios. Goodbye.